Okay, this is part 3 of our focus on ANOVA for section 10.2. So the ANOVA test is an overall test. A significance test result tells us that we have strong evidence that at least one population is different from the others. But it doesn't tell us which one is different. So there's many different follow-up tests that can be done. We'll use pairwise confidence intervals for the difference in two means, as we did before. So, key idea, if a ANOVA test finds evidence that there's at least one long-run or population mean that it's different, there are many different follow-up tests designed to help pinpoint where the differences occur. One option is to look at all the pairwise theory-based confidence intervals for the differences in long-run or population means. So, when you have an F statistic selected from and the F distribution overlaid, you can check the box to compare 95% confidence intervals. So if we go over here, no, I think maybe over here. 95% confidence intervals. Okay. Report the intervals for A through F. So remember, my numbers will be different from yours. So I would just report this for A, B, C, D. Make sure they line up. Okay. For number 16, which of the confidence intervals calculated in exercise on number 15 indicate a significant difference between the groups? I've got a fun fact for you. The little asterisks are the ones that are significant. Notice that my one with the asterisk has two negative numbers, whereas ones that don't have asterisks, they have a positive and a negative number. Okay? So, now, based on your analysis, would you conclude that there is one diet that works significantly better than the other three? If so, which one? So go ahead and answer that question. Use your common sense and knowledge of the world. Okay, now let's talk about validity conditions. So whenever we're doing a theory-based approach, we always have to be aware of our validity conditions. So for the F distribution, it's good approximation to the null distribution, as long as either the sample size is at least 20 for all the groups without strong skewness or outliers, or if the sample size is less than 20, then the distribution of the response variables is approximately symmetric with all the, kind of like a bell-shaped curve, okay? And then the standard deviation of the samples are approximately equal to each other. The largest standard deviation is not more than twice the value of the smallest standard deviation, okay? So do the sample data for the diet study appear to satisfy validity conditions? So here, I have samples that are more than 20 and no extreme skew, and I have, let's look at their standard deviations. So if we're looking at the standard deviation numbers, then is any one of them more than twice another one? No. So in my case, with my data, where I deleted some of it, I matched the validity conditions. Okay. All right, for number 19, are you comfortable with concluding from this study that the diet you use causes a difference in BMI change? Justify your answer. So this number 19 should, like justifying your answer should refer back to like what we just did, okay? To what population are you comfortable generalizing the results of the study? Justify your answer. So that's relating back to some of the early questions at the beginning, okay? So looking back, did anything about this design conclusion to the study concern you? Issues you may want to critique include the match between the research question and study design, how the experimental units were selected, how the treatment was assigned to the experimental units, how the measurements were recorded. So pick at least some of those and write some full sentences about what you think is fine, what you think needs to be changed. Looking ahead, what should the researchers' next steps be to fix the limitations or build on this knowledge? So anything that you picked out or critiqued in number 21, suggest something, a better way to do it in number 22. Use full sentences, okay? That completes this section.